Hello everyone, welcome to the presentation of our project, Building a Word Embeddings Repository for Turkish. We worked on this project as a group of two, me, Karan Sarıtaş, and my friend Cahil Öz, and we were advised by Professor Tunga Güngör. Before starting, let's briefly describe what a word embedding is. A word embedding is essentially x-dimensional representation of a word in a numerical manner, and our aim is to create similar word vectors for the words that are semantically related to each other, and also vice versa, creating distant word vectors for the ones that are not really related to each other. And to do so, there are two kinds of embedding strategies: contextual models and static models. Although contextual models are right now performing better compared to the static models, we strongly believe that static models are still widely used because they require less resources to train. It's much more easier to train them, for example, just using a library like GANSIM. Whereas for contextual models, you have to have labeled data. It's a supervised procedure, and most of the time you have to utilize GPU resources, and it's much more easier to deploy static word embeddings as well. A comprehensive study which covers the evaluation of different word embedding creation methods for Turkish didn't exist, and our motivation is to create a word embedding repository that has some pre-trained word embeddings, also scripts, notebooks, and so on. We have worked on 5 different word embedding construction strategies. The static ones are word2vec, glow, and fasttext. And Elmo and BERT are contextual models. By contextual models, we mean that they generate word embeddings for words according to the context in which they are used. Whereas static word embedding models generate their embeddings beforehand, and embedding corresponding to a specific word doesn't change from one context to another, but of course it has some downsides. But as I suggested earlier, using or training a contextual model from scratch requires so much resource to use. To compare the performances of our models, we have two strategies: intrinsic evaluation and extrinsic evaluation. Intrinsic evaluation has two categories: analogy and similarity. Analogy tasks stand for actually answering the queries such as if A is to B, then C is to what. For example, the very classical example of it is if man is to king, then woman is to what. And we expect our model to return queen. Another example can be if king is to kings, then queen is to what? And the answer is queens. In this case, we are trying to utilize the syntactic similarity between the words. And the whole idea actually is coming from the vector algebra, where we just subtract one vector from another and trying to get the result. And the second task is similarity task, in which our aim is to correctly predict or calculate the cosine similarity between the provided pair of words. And we have the labels, the actual similarities, and we are trying to find the correlation between our founding and the actual labels. In order to calculate the correlation, we can use Pearson's correlation or Spearman's correlation. High correlation means our model is performing as expected, and low correlation means we have to improve our model, there is some problem with it. For our experiments, we have actually combined two corpora. The first corpus is coming from web corpus, which was prepared by Tulap, and the second corpus is Huawei corpus, which was prepared by Yıldız and his friends. And we have prepared some small package to help with loading our trained word embeddings and running similarity and analogy tasks, which can be found publicly available in our repository. We also provided some scripts to generate LaTeX tables from your after running your analogy tasks or similarity tasks and getting the results. In addition to the evaluation scripts and documentation scripts, you can find our notebooks in our repository, which we have used for our NLP tasks. You can find some of the scripts that we have used to train our word embeddings. Also, some of the already trained word embeddings in our release section, so that maybe you can use them for your NLP tasks very easily. In addition to the repository that we have maintained throughout the semester, we have also provided a basic web service called Turkish Web Vectors, which can be found online at the address turkishwebvectors.software. And our main motivation is to make the word embeddings much more easier to understand and make the whole concept much more concrete. And our features include running analogy and similarity queries, or visualizing your higher dimensional word vectors in just two-dimensional space using different dimensionality reduction algorithms. Lastly, we hope to finalize our paperwork in which we provided a comprehensive analysis of static word embeddings for the Turkish language. Thank you for your attention.